in this problem, we want to calculate flux. Flux is given by the integral over S, f dot n ds. That is our flux integral. It is a type of surface integral. In this problem, we are given the vector field with components zx squared, cosine y, e to the x sine y. S is the surface of the box bounded by x equals 0. So that's x equals 0 is a plane, right? So that's going to be part of one. That plane is going to be part of one segment of a box. That's the YZ plane, right? X equals 0 is the YZ plane, but only part of that plane will be one face of the box. X equals 1 is another face of the box. Y equals 0. Y equals 2, two more faces. Z equals 0. Z equals 1, two more faces of the box. Any rectangular box has 6 faces. So if the surface S is represented by the union of those faces of the box, well, any particular face is a smooth surface, but the union, it would be the union of smooth surfaces, right? At the edges, it's not smooth. And this formula would work perfectly well as long as you're willing to set it up for all 6 faces and then add together. In case you're not sure, that would be no fun, right? It would be no fun to evaluate 6 flux integrals. But good news, it's a closed box, right? And the divergence theorem is going to work just fine. So what does the divergence theorem say? If E is the interior of that closed box, then that flux integral is equal to the surface integral. The flux integral is equal to what I meant to say is the triple integral over E of the divergence of F dV. And so that's a huge time saver. That's telling us all we have to do, well, you guys tell me, what do we calculate first? Divergence. And then the faces of the box are flat planar faces, so the limits of integration are going to be constant. So it shouldn't be too bad at all. So let's calculate the divergence then. Now, remember what the divergence of F is. It's thought of as del, where del is a pseudo vector with components that are operators, right? d dx, d dy, d dz. Del dot F. So basically, we take d dx of z times x squared. What's that going to be? Derivative of z times x squared with respect to x? 2zx. I don't know why I didn't do it in alphabetical order there. I'm gonna do it 2xz here. Does that make sense? And then take the derivative of the second component with respect to y and add it to what we have here. What's the derivative of the cosine of y with respect to y? So negative sine y. So let me just, instead of saying plus and negative, let me just write minus sine y. And we're adding, right? The dot product is going to be a scalar. Well, in general, a real dot product is a scalar. So del dot f, a pseudo dot product, will be a scalar function, right? So then add that to the derivative of this guy with respect to z, which would be 0. 2x z minus sine y then. So that's your integrand, isn't it? Now, if you think about it, I think we can even avoid drawing a picture here, since the limits of integration will be constant. So we have 2xz minus sine y. Let's go with the usual order, dz, dy, dx for our differentials. And then let's go back to where we were given the plane faces of our box. What does z range from? 0 to 1. What does y range from? 0 to 2. And what does x range from? 0 to 1. And I'll go ahead and put parentheses around the integrand. Otherwise, it looks funny. At least to me, it does. Want to evaluate this thing? Okay, what do we get? Hopefully it's not a hard one. Okay, integrate with respect to z. 2xz would just be xz squared. Okay, sine y is a constant with respect to z, so what do you get? So minus z sine y. And then we evaluate this from, remember, it's z equals 0 to z equals 2. And then dy dx on the end still, right? Z equals 1, excuse me. There we go. And then, okay, evaluate it. Upper limit. What do we get? So just x and then minus sine y. If you plug in 1 for z, now we still have to apply the fundamental theorem. Do we get anything if we plug in 0 for z? Oh, I think everything zeroes out, right? So maybe I won't write that part down. Okay, and then dy dz. dx it should be. All right. Does that look better? Okay. Integrate with respect to y. So xy. Yeah, so the integral of sine would be negative cosine. So plus cosine y. Evaluated from y equals 0 to y equals 2. And then we still have the dx in the end, don't we? Okay. Okay, so plug in. What do we get? 2x plus cosine of 2 minus, okay, wait, 0 plus just 1. Cosine of 0 is 1 though, right? Yeah. Then dx, and if I clean that up, I get integral 0 to 1, 2x plus cosine 2, which is just a constant, and then minus 1 dx. See, it's not too bad. I made it look a little harder than it is, but it's not bad at all. X squared, if you integrate, x cosine 2 or cosine 2 times x, right? But it's probably better to write x cosine 2. Otherwise, it looks like you're taking the cosine of 2x, right? Minus x. Evaluated from 0 to 1. Okay, what do you get? 1 plus cosine 2 minus 1. And then anything when we plug in 0? That guy zeroes out, that guy zeroes out, that guy zeroes out. So we're just left with cosine 2. That one's not bad at all. Wouldn't be a horrible one to put on the exam, would it? Not saying that's what's going to happen. I'm just saying it wouldn't be bad.